All right, so here's a few news articles worth mentioning. This one is interesting, although kind of hard to understand. There's this thing called indistinguishability obfuscation, and it is considered the holy grail of cryptography. If you could, which means you can make it so that you cannot understand the source code of the program that you're running. And so in principle, if there were two different versions of the source code, you could not tell which one was being run because it goes through obfuscation. And this was thought to be impossible, but somebody has now made it possible. So they say it's not practical right now, but it is possible that this will be the fundamental primitive used to build all future cryptography things. So that is an interesting issue, sort of like quantum encryption, quantum computing, one of these things that may be more important one of these days. A spam king, American neo-spam king, was just ID'd by DNA. A student posted this. A neo-Nazi spam king. Oh, okay, yeah, one of these guys. Yep. Wolfgang Hawk. Yeah, a bunch of these guys are often out there. And so they found him. Okay. Yeah, I know this book Spam Kings by Brian Krebs that I got years ago talks about this. And the people that run spam are basically classic mafia type organized crime figures in Russia, and they kill each other and stuff, making all their money over spam. So anyway, and so this is something I didn't know. People are talking about what's going on with Trump, right? Trump is refusing to admit he's lost the election and bringing a bunch of lawsuits, but the lawsuits seem to be ridiculous and they're just going to get thrown out. So people wonder what's going on. But one thing that might be going on is that he's going to subvert the Electoral College. And I was surprised how often this has happened before. There's a chart here. There. These are the number of Electoral College representatives that were faithless and voted against what their state had wished. And it has happened many times before, and sometimes up to 30 and 40 electors have done this. It has never been enough to reverse the election, but in principle, this could be done. A Republican state legislature could just put in electors that will vote for Trump, even though the majority of the voters in their state voted for Biden, and that would be legal. It has never been done, apparently, but people are suspecting this might be what the plan is. Anyway, by delaying things, they can somehow, most people think it's unlikely that Trump will succeed in staying in power, but they're trying to figure out what's going on because Trump and all the Republicans seem to be in lockstep, saying we're just going to deny that Biden won and demand that Trump wins and find some way to ram it through. So we're living through an attempted coup, and it's just not clear how seriously to take it. So the new Macs are out with their ARM-based processor. They say it is much faster, and of course that means it cannot run any legacy code for Intel, so people are saying it's useless, but it is going to include a translation library. Just like if you took the Android class, we run that on x86 and we have an ARM translator, so this includes Rosetta 2, which will emulate an Intel processor. So you can run Intel-based code, but it probably will run more slowly, and there probably will be some bugs and limitations, but anyway, it's out. In a week or so you can get it. The new MacBook Air is supposedly much faster and based on ARM, which I'm interested in, although I'm not rushing to get it just yet. Anyway, the other thing I wanted to be sure and tell you is the guest speakers. We had one last night that was very good, and we've got on Tuesday, we've got these people coming from Qualcomm, and I just got on Saturday after that, David Gerard is coming. He's quite a well-known guy, writes books on cryptocurrency. I included some of his book, this book in my cryptography class as a supplementary textbook. He is very important because he writes books explaining the financial consequences of cryptocurrency and how it has failed most of these financial purposes. Around here, you may have met cryptocurrency enthusiasts. They're like fleas on a dog around here that believe that cryptocurrency like Bitcoin is going to save the world, and it is wonderful and everybody should invest in it. And all the traditional financial people don't feel that way. And I'm one of those traditional financial people that doesn't feel that way. Anyway, so before you invest in cryptocurrency, you should read his books. And an enormous number of people remain enthusiastic about them. Anyway, I'm very glad to have such a prominent fellow coming. It's on Saturday afternoon. So check it out. It will be videotaped, but if you show up live, you can ask him questions. And I would think a lot of people might have questions, especially if you're thinking of investing in cryptocurrency. Please talk to him first, because it is not at all as good an investment as people make it sound like. Anyway, so check those out, and a lot more talks coming after that. Anyway, that gets us to the official time. And so we're here. This is 126. And by the way, Caitlin gave us this talk about satellites last week, and now there are the first project to work on that stuff is out. She's writing hands-on projects to do that satellite stuff, which of course is off topic. But I made a space section. It's here. You can do it if you like. This is the first one where you take an image, which she gathered, and then you install the decoder and decode it. So that is part of the process. I've got the pieces, almost all the pieces now. Some are still coming to make my own antenna. I've got my software-defined radio. I'm planning to get that one going and write it up. And I found out I should have my ham license soon. The ham test is actually very easy. So, you know, I'll add things here as we go. I'm going to totally do what she's doing. Get a ham license, make it so I can talk to people on the space station, pick up I'm all interested in it. So there'll be a series of these that Caitlin or I will be writing. And of course you can do them, but they're not directly related to malware. But I think it's very interesting. Anyway, so today it is here, covert malware launching. Let's talk about this for a while. So the point here is, as you may remember, if you remember the old days, like the MS Blast worm that would infect your machine, all you had to do was open Task Manager and you'd see Blaster running. How many ham license classes are there? I know this because I've been practicing the test. There are now 3. And I'm only getting the first one, but there are 2 more beyond it. There used to be others, but now there are 3. And if you get the first one, that's enough to talk to the satellite. You can send signals to satellites and control them, and you can talk to the International Space Station. So that's Morse. You do not need to learn Morse code to get a ham license. All you have to do is answer a multiple choice test, and it is incredibly easy because the entire test bank is available to practice on. You really just memorize the answers, but you learn a lot of stuff. It's actually pretty interesting. Learn about the Van Allen belts and stuff like that. Anyway, so you used to just be able to see the malware running in Task Manager, which is true, for example, of the fake malware you're using in this class. You often go into Task Manager to kill it. But of course, that is not very covert, and that's pretty weak malware. So now they try to blend it in with covert launching. So the point of a launcher is that it's going to launch a malicious activity, and it's not going to be obvious. So typically what it does is the actual executable you run is not malicious. But the executable you run then goes and finds another program in the resource section, loads it into memory, and runs it. And I did this years ago using Python, and even though it's an old trick, you can bypass almost all antivirus with this trick because it does not look in the resource section for malicious code. It just looks in the running code and doesn't realize that the other code that looks like data is actually going to run. And you could, of course, encrypt it or compress it to make it even harder for an antivirus program to recognize that it's malicious. When you do resource extraction, you use one of the resource API calls, or several of them, to connect to the resource, find the data segment, and copy it into RAM, then make it executable, then run it. Just like the UPX unpacker that we talked about in the past. So there's ways to covertly launch it. Here's the types that are used: DLL injection and direct injection. And the point is to add it to a process that's already running. So this might bypass your security mechanism. So use virtual alloc X, for example, to allocate space in another process's memory and then write into that memory. So you can add running code to a process that's already going, and it will run with the privileges of that process. Another way, of course, is DLL injection. You can inject code into a remote process. You can add a DLL to a remote process, and as soon as you add a library, it will load the DLL main. So you put malicious activity in the DLL main, like the Metasploit malware we were making earlier, it's already used for this purpose. So if, for example, if you have a launcher, now the Windows firewall is application specific. It will say this application can connect to the internet, but other applications cannot connect to the internet. So if you just download something and run it, it is likely that the program you're running does not have the ability to access the internet. But what you can do is just inject the code into Internet Explorer and get to the internet that way. So that's what this looks like. You're running your launcher malware. It's on the hard drive. You double click it, it loads into RAM. It then tries to go to the internet, but that's blocked by the Windows firewall. So what it does, you run it and it injects a DIL into iExplorer, and that goes to the internet. So that's the idea. So here's the pseudocode to do this. These are the Windows API calls. So you have a handle to the victim process from the open process function. And then you get a process name with this virtual alloc x. You get, this is a name of a memory region. You have a handle to that. Then you write data into the process memory there and load library A to get this address. And then you create a remote thread that will load this DIL in there. So that's the game. With the Windows API, Microsoft allows you to do this, to add code to another process. And once you have the ability to execute code on the machine, you can do it. So here's what a debugger would look like. You open the process here. Here's your allocating memory. Here it is writing into that memory and then loading a library. And here it got the name of the module. So, it's just standard API calls. And all these things are. So the malware is not doing something amazing like, an exploit where you trick a program into doing something it shouldn't be able to do. You're just using the Windows API as intended. Why does Windows allow you to just add code to another process? Well, that's a very good question. And everything we talk about today is going to be abusing Windows function. For some of these, it's pretty obvious. The simple thing I can think of is you might have some unusual hardware, like you get a Bluetooth keyboard. And so you want to have it go to a different place to read keys and expect things to come. Or you have a funny monitor that needs a special driver or a printer. I think that's the idea. That's how all this happens. You want to modify the function, the behavior of something. And it turns out, this is true of everything in Windows. There's always 50 ways to do everything in Windows. So instead of having one standard way and some security boundary, they just add another way to add code to processes until there's like 50 ways to add code to a running process. Just so that everybody can, as rapidly as possible, manufacture software and hardware that does anything and make it work with all your stuff. Because Microsoft, like Facebook, is trying to add features as fast as possible and to let you reuse code from other operating systems and older versions and mix old hardware and the new OS, so they have many, many ways to patch things together. And of course, malware can abuse them. So that's my general answer. I don't have a very specific one more than that. And when we get down a little later to the asynchronous procedure calls, I spent a while Googling today trying to get any explanation of why they work this way. And I could not find anybody explaining why this feature exists. But it is a technique that is used by a lot of Windows, and it's in there. So I think the ultimate answer is a lot of programmers found it convenient to have this feature. So Microsoft just threw it in. So anyway, direct injection is, of course, the other way. And here you're doing something which is certainly not a deliberate thing you expect you to be able to do. This is what we did with PuTTY earlier in Ollie. You modify the code, change the code in it. And therefore, if you're going to be sloppy and break the host by just ramming in code like we did with PuTTY, that's easy. But if you actually want to modify a program so that it will still continue to run and not make anybody suspicious, but also have undocumented extra features, then that can be done too. And typically what you do is you find a code cave, which there's easy to find, the programs that will do it. You find an area of unused code, and then you just stick your malware in there and then hook it in with a hook that will allow the normal function to be called most of the time. Anyway, that's the game here. It's much more difficult than just connecting to a malicious library. Okay, and then there's process replacement. If your process can be paused, you can take the memory contents out of the process, replace it with a new process, and resume it, and now it continues running, doing something different. And this is, of course, quite nice. And typically you replace svc host.exe because, as we looked at last time, there's typically a couple of dozen instances of svc host running, hosting all these background Windows services, and a bunch of them you're not using. So it's perfectly fine to stop them and replace them with something else and nobody will notice. And they're often running with system privileges, so it's a privilege escalation technique. So you put it in a suspended state, and now you can replace the contents and then start it up again. So you create a thread suspended, and then you connect the thread to the process, and set thread context and resume thread, and now that's inside. Does the Process Explorer detect this using verify image? I would think it would. And remember, we had one of the earlier malware samples we looked at before. You could look in Process Explorer and you could see that the image in RAM did not match the image on the disk. So you can detect it, but it doesn't seem to be flagged by any intrinsic Windows process. So it's not like it's extremely subtle, but there's no built-in defense for it. And by the way, if you didn't see last night's talk, you might want to look at the video, because you can totally do this in the cloud. Let me bring this up. In fact, last night's talk was one of the talks from FireEye, and it's now on my old classes page because we're getting so many talks suddenly. I couldn't fit them all there. So should be here. Maybe I have to refresh it. If I lost it, I'll talk about it later. There we are. Let's see. This one, this one, this one. There we go. Sergio Nevarez. And this thing here, he talked about how if you are using Amazon Web Services, you get these tokens like OAuth to manipulate your machines in the cloud and use and access your Lambda functions that are running in the cloud. And you can add a Trojan Lambda function in the cloud, which every time someone connects and authenticates, it will make a second authentication token and send it to a third party so you can steal it. So it's like a keylogger in the cloud. And it is pretty awesome. You can totally do it on Amazon. You can poison somebody else's Amazon cloud environment, so it's giving you backdoor keys all the time, so you can get in and impersonate any of the users and do unauthorized things. And when I asked him, how do you prevent this? It turns out that there's something called CloudTrail, which is like event log for the Amazon cloud. And you have to watch for the specific CloudTrail events that accompany this process. There's no simple way to do it. So it's quite similar to this attack here. And by the way, this also reminds me of something else to point out. I put it in 152, but you can do it in this class too. If you want to learn more about the cloud, which I highly recommend, I added a cloud section here, and I found it this morning. So there should be, I already mentioned this Azure Fundamentals class, this free online class to learn Azure. There's the same thing for Amazon. So I highly recommend doing these. These are both a whole series of free online classes. You do them, all you have to do is make a normal Amazon account and go to the free digital training. And you can take these classes, and I did 3 of these little things this morning, and there's like dozens of them. So if you don't know much about Amazon Cloud, you should totally learn it. The same thing for Azure. This is where everything is really being done these days. And for free, you can take little classes and practice setting it up and learn how it works. The Azure stuff gives you a lot of hands-on. This Amazon was just quizzes and videos as far as I got, but there might be hands-on later. Anyway, I highly recommend it. You'll find it in my 152 class. And all these tricks are happening in the cloud, and that is where there's a real demand for people who understand how to secure the cloud. The one lesson I got from his talk last night is that the cloud is very terrifying. It is so confusing and so complicated that it is pretty easy to just put a couple servers in a cloud, and it is really hard to understand how to correctly monitor them and block the attacks. And this is why the #1 concern of every business about moving to the cloud is security, and they are right. And every week there's another person that gets breached because they put their stuff in the cloud unsafely. And it is obviously very easy to do that. So if you get any familiarity with how to secure stuff in the cloud, that will look really good on your resume. Anyway, let's try these Cahoots. So this is 126.12a, all right? So I highly recommend getting some practice with the major cloud providers and learning the various terms and techniques used there. And I will try to add hacking projects in the cloud as soon as I can figure out how to do it myself. He demonstrated a couple in that talk, so I should be able to write that stuff up as projects, and that's something I'll be trying to do soon. 26. Give it a few more seconds. This will bring up the class. Okay, I guess that's it. Okay, so where do launchers find the code? That's where it is, typically in the resource section. This would be a downloader, and this is like a DLL connected to it. This is how Stuxnet works. Stuxnet had a DLL right on the stick that would be loaded by the executable. But anyway, the resource section is where you hide malicious code so it doesn't look like an executable. All right, and which one uses a suspended state? Okay, process replacement. You suspend it, you replace the code, and then you resume it. And which one requires customized code? Okay, that's direct injection. And the most common launching technique. Of course, DLL injection, it's so easy. Metasploit will just make the DLL for you, you know. You don't have to customize it. It's obviously the way to go. All right, and what's find resource good for? All right, that's the API you use, one of the API calls you use to find that resource section and copy it into memory. All right, so all right. You'll have to tell me who you are to get your points, but those are good names. All right, I see one up here. All right. All right, I see two of them. All right, the only one missing is AD. That might even be initials. Anyway, so let's go here. And, all right, so now there's hooks. Yet another way to do the same thing. Your Windows has messages in, I see, thank you. AD is initials. Let me just make a note. All right, anyway, so, all right, so your program sends signals to other programs like interrupts. In Android, they're called intents, and in Microsoft, they're called messages. So if you do something like click the mouse or press a key or something, then that sends a message. Somebody has to deal with it. A key has been pressed. And so your list, those things are the hooks intercept the messages and grab that and do something before the normal process would happen. And so you can make a malicious hook. So normally the user does something like press a key press, the Windows OS turns that into a message. The message goes to threads that might be listening for that event, and then they process it. But you can add a malicious DLL, and it will then do something different before passing it on to the threads. And like I said, this is what you would need if you wanted to have an unusual kind of keyboard or mouse or monitor or something. You would have this software that came with your interesting device, and it would then catch the messages that would normally go to the boring old default device and now go to your new fun device instead. So it's obviously valuable for developers, but for bad guys too. So you can have local hooks that manipulate messages intended for the same process that would be handling it otherwise, or a remote hook that manipulates a message and then passes it on to a different process. So high-level remote hooks require that the hook procedure is an exported function, and that'll be one of these shared libraries, or low-level remote hooks will be directly contained in the same process. So you can make a keylogger. Keyloggers are a common type of hook. They want to catch key presses, and so they will use these procedure types. Keyboard or keyboard LL will be hooks that capture keyboard events. And so you use set Windows hook, the API, to do this, and then you have types of hook, pointers to it, handles to the DLL, and so on. Then you call, when you're done doing your hook code, you then call next hook so that it can proceed to the next hook, and there can be a whole series of these hooks. And it's the same way the structured exception handler works, which we talk about in the exploit development class. You add this extra code, and then when you're done doing whatever you want to do, you pass it down the chain to the rest of the code and resume normal processing. So if you loaded all threads the way keyloggers do, then of course you're going to burden the system and slow it down, and you might get caught. Your local anti-malware intrusion protection system or something might detect it. So keyloggers have to do that if they want to catch keystrokes from every thread, but other malware might be able to target just one thread. Now, if you're going to try to be subtle, you might want the malware to not be triggered by any ordinary event. There are, just like there are a bunch of API calls and a bunch of loaded services that almost nobody ever uses, there are some events, messages that are never used, like this one, computer-based training message for some special service that's not being used. So that would be one you could hook safely and then generate that from your malware and be sure that nobody would ever care that you're using that one. So here's hook injection in a Notepad. We're going to add hook.dll with malware proc, call next, hook exit at the end, and it's going to watch for, it's going to make this WHCBT method to make this happen. So here it has the hook.dll, it loads the library, it gets the name for the malware process here, and then it sets a Windows hook that's going to take effect when it gets this WHCBT method. So these are the API calls in assembly language that would be used to do that. And there's yet another way. I remember feeling just sort of maddened when I saw this, like when I saw the first auto start extensibility point list. There are so many ways to do something unwise and dangerous in Windows. It can make you sick. So here's detours. And here's the idea that you might need to take old code and run it on a new OS. And so you want to have a quick way to modify it to make that happen. So you create a detour section. And this is now a new bunch of code that runs before you make the API calls you were going to run. So you have text, data, resource, and then detour. And the detour has a second import table that catches these API calls and runs them through extra code. So, you know, it's just designed for malware. And if that's not enough, there are things, I tried to figure out what these APCs are for, asynchronous procedure calls, and the best I could understand them is you might be doing something like saving a file. I remember back in the old days of MS-DOS, I would edit a program, and when I, like a word processor, in Word or something, when I wanted to print it, I'd go get a cup of coffee, because while it's printing, you can't do anything else until it's done, because it was not a multi-threaded system. Now it is, though. So if my program is, say, saving a file, I can be doing something else. So something is happening when my one program is running that is asynchronous with the other processes. And the way it does that is there is a queue of things waiting to happen asynchronously, and you can just add a job to the queue and it will be processed in due course. So that's what this is. You add something to the queue, and it'll be processed when the thread is ready for it. So when the thread is in an alterable state, that means it can run these other things. So you can have kernel mode APCs and user mode APCs, and you inject them. It's adding a job to the queue. So if you wanted to do from user space, you'd call queue user APC. The thread must be in an alterable state that will let you change this, sort of like suspending it. And then wait for single object is the most common thing, which will wait for it to become alterable. And then you have a chance to add something to here. And this, I think, is what's commonly done because you don't want to tie up the processor and make every job wait for your job. So instead of demanding single control of the processor, you do almost everything this way by just adding jobs to queues, which will be processed at whatever time the right time comes, which is why, by the way, for satellites, you cannot use Windows. And for cars, you can't use Windows. You need a real-time operating system. Real-time operating systems don't do this. You know exactly when something is going to happen. But Windows is emphatically not a real-time operating system. If you launch a program or a network event happens, you do not know when that will take effect. It will get around to it whenever it's in the mood to get around to it, when it's done all the other things. And that's the way it is. You just add it to some queue, and it may or may not ever get around to doing it. So you have a handle to the thread, the function to run, and parameters for the function. And so off you go. You open the thread, you call this queue user APC, and that will define this activity to be processed when the Windows decides it is time for that thread to execute its APC queue. And you can, if it solves some problems like moving from kernel space to user space. The most common situation, of course, is you're in user space and you'd like to do something in kernel space, but you can't. But if you're a kernel mode rootkit, it can't execute user space code easily. So what it does is inject that code with these kernel calls, which will inject a user mode APC, which will then be processed later in user mode. And here's how it looks. You set up the parameters and call kernel initialize APC, and then insert it on the queue. So it is a way to get a job done with a different privilege level than the process that launched it. So this is, I think, the dirty secret of all security is what look like security barriers are in fact not that hard to circumvent. This is like most laptops. If the hard drive is not encrypted, your login is just like a TSA key on your luggage. Anybody can just boot from a stick and get right past it. It's really not much of a barrier. All right. And of course, most of these require you have administrator access on the Windows machine, and that's why Microsoft doesn't take it too seriously. What means by alterable state during print queue? Yeah, an alterable state is like suspend. It means that thread is paused, and it is possible to add more things to the queue. It's not exactly the same thing as suspending it, but it means that you are allowed to change the queue at this time. I would imagine while processing functions on the queue, you are not allowed to change the queue. That's all. But it turns out that most processes are alterable most of the time, which I think just means they are not currently being executed, and so they could be changed. Anyway, but I have an imperfect understanding of it. That's as close as I've got at figuring it out. I'll give it a few more. Yeah, I thought there were 16 last time. I'll wait a little bit. All right, guess that's enough. So, which technique manipulates messages from a process to itself? It's a local hook. That's what's local. All right. All right. Which one will hook all processes? Keyloggers got to hook all processes to get all the keystrokes. All right, which one adds a new section to the PE file? Okay, that's right. Detours are there as a new section. All right. All right. If a kernel mode rootkit wants to execute user space code, what does it do? Asynchronous procedure calls. All right. All right. And which technique only works when a thread is alterable? APC. Good. All right. So it's Cloudy. All right. I know who that is. Craig, I know who that is. And www, tell me who they are. All right. Okay, good. I see who they are. All right. That's good. So, all right, I'll stop this recording.